Hi everybody, welcome to the day 2 session of Informatica Power Center. Can anyone please confirm me if my screen is visible to you and I'm audible? Great, thank you so much. So there we are. Today we will try to learn more about the architecture of Informatica and the different schemas available in data warehousing, that's like Star, Snowflake and Galaxy. We'll learn more about it. First of all, let me start with the Informatica architecture. Yesterday we have seen like Informatica, like any other tool or say any other desktop application, again has two components. That is, we have something called server, right? And again, we have something called client. Okay? Then for the server and the client to communicate in between to get the data or say resources, we have something called repository in between. Okay? Now what is this repository? We will get to know more about it. Team, can everyone mute yourself please? For the convenience of taking the session, I'm not able to control that particular thing. Okay, now let's go on with the flow. So here we have a server and a client, and there we have a repository. Now what does this repository do? We have right, this is a repository. Now what is the basic functionality of a repository? Why do we need a repository to maintain the server and the client tools of Informatica? The basic functionality of a repository is, or what is a repository? The answer is like, it is nothing but a relational database. Okay, and what does this database contain? What data does it contain? It contains nothing but the data of data, or say the metadata, right? And what is this data of data? We have many sources, right? We have many sources, we have targets, and we transform all the data from the sources to whichever format we want, or to whichever required say need, and then we transform the data from the source to the target. So the transformation details, the mappings and the workflows, all the data of such kind of definitions as the source definition, the target definition, about the details of the transformation, the mappings and workflows, it contains such kind of data. The repository is nothing but it is saving the data of the source definition and the targets and other details, right? Then we have something called, we need administrative privileges, right? To work with the server and the client tool of Informatica, we need to have some roles, or say there will be roles, right? If you are an administrator, then you will be having some kind of privileges. If you are being using it as a user, normal user, then you will be having some other roles and privileges. Everyone doesn't have the same permissions to access everything. I mean, say the repository or everything, we will be giving access according to your role. Say if you are a user or if you are an administrator, based on that you'll be given the privileges to read or write the database. So it also contains the permissions granted for each user and the username details, and say if you have some passwords assigned, right? So these kind of details are saved in the repository. So the basic functionality is like, when you have to get data from the Informatica about the transformation for the source definitions or target definitions or any such things, then you need to, then the client or say the server contacts the repository to get the details and then perform the task, right? So that's the basic functionality of repository. Now coming to, what is this server? We have Informatica server connection and also we have client tools. So what does this server perform? It basically consists of two components, that's nothing but repository server and integration server. Now we have something to save the data about the sources, targets, say transformations, mappings and everything in the repository. But when we need to perform a task, or when we need to execute a workflow, or when we need to transform something, say if we have scheduled something, say if we have scheduled a session or if we have scheduled a task to be performed at a particular time. So you want to run a job at 3 a.m. in the early morning, and the job will be running and there will be some batch jobs which will be performed at the back end, and that will be triggering your workflow. So the execution of the workflow, the scheduled task, all will be assigned or say will be integrated in these two components, and they will be in communication with the repository to fetch such kind of data about the sources, targets, and what kind of transformation is being required by that particular workflow or say that particular mapping. So that kind of duties are performed by these two components of server. Now we'll learn more about what is repository server again. Say, let me take something else. Say in the repository server, we have what are the basic functionalities of that? It is nothing but it manages the repository, or say the metadata. Now what is this doing? The repository server manages the data which is present in the repository. Okay, you are saving the data of every source, target and other particular mappings, workflows in the repository or say the database. Now you need someone to manage it, right? You need someone to take care of it and provide the necessary information when the client tool asks for. Okay, so that's the basic say functionality of the repository server. It manages the repository or metadata, and then also what does it do? It manages the connections, okay, to the repository. Now, say when you are connecting to the database with a source and target definition. So you need to get access to that particular database with a connection string with some username and password provided, and also those things are also managed by this repository server. And all those permissions and all the privileges will be granted by, or say it will be saved in this repository. So this server gets access from this, and then it manages such kind of connection strings to the source and target definitions, right? And what else does it do? It also manages the insertions, updations, and deletions of the data present in the repository, right? That sounds great, right? Because we have data in the repository, but if say we want to update something regarding some source definition or target definition, or say we want to update the mapping, or say if we want to change something in the workflow and everything, then all such kind of operations, insertions, updations and deletions of that particular kind of data will be managed by the repository server. Okay, then what else does it do? It also, I'm sorry, what else does it do? It also maintains, or say it ensures us consistency of the metadata, right? Say we will be given some kind of consistent data assurance about the say about the source definitions or the target definitions, or say about the permission granted for a particular user. We find such kind of data assured, or say consistency provided by the repository server. These are the basic, or say some of the functionalities which the repository server provides. And then moving on to now integration server. Right? What does this integration server do? We have different kinds of mappings, we have different kinds of workflows, and then we have some kinds of sessions which performs particular tasks and all according to the scheduled time, and according to the say assigned tasks which will be performing after the batch jobs have run. So that particular duty is performed by the integration server. What does this do? It just reads mapping and session information from the repository. Now we have done everything. We have saved the details of the mapping sessions and everything. But when we want to, when we have say some request from the client to perform a particular task at a particular time and for a particular mapping, and that will be again assigned with some kind of transformation in the data from source to target. So all those will be managed by the integration server. It reads that particular mapping, and then it will transform the data if there is a transformation assigned to that. Can everyone please mute yourself, because I don't understand why I'm not able to mute you all. I still hear something. Is it from Igor? Can you please mute yourself? Okay. So we will find such kind of mapping and session information executed, or say performed by the integration server. Then what else does this do? It will again extracts data from mapping sources and stores that data, right? So it extracts the data from the particular mapping when the request has been sent from the client, and then stores data, and then performs the transformation which is assigned to that mapping, or say executes the workflow based on the configuration and the transformation rules, right? Then we have other functionality of this, which says it also helps to load the transformed data to target, right? We have got the data, we have executed it based on the mappings and transformations, and also based on that we'll be loading the data into the target with the help of this integration server. This particular integration server takes the privilege to perform such kind of duties. Okay. Then it also has other functionalities, like it also manages and say executes the workflows, or say sessions, or say tasks which are assigned, or say which are requested by the client. So these are the basic components of server which will be performing various functionalities. Okay, right. So we have understood about what is a repository and what is a server. Now let us move on to what is client. Okay. Now what does this client do? We have, as I have said, Informatica performs like a desktop application. We have server, we have something in between the server and client to perform. Now what will this client do? If the user wants some kind of operation, or say some kind of task to be performed, then it sends a request which will be say granted according to the permissions or the privileges which the user can have, and then based on those permissions, also based on those privileges from the data in the repository, then it will be performing the tasks which will be requested by the client from the integration server and the repository server. Okay. And the client again has different kinds of components. What are these type of components? Basically it has 4 type of components. They are nothing but the repository manager, then we have the power center designer, then we have something called the workflow manager, and then again we have the workflow monitor. Okay. Now what are these kind of components doing with the client application? We will see one by one. Okay. Coming to the first thing, that is the repository manager. We have a repository here. We have a repository server in the server side. Then again, what is this repository manager doing in the client side? The same, the information about the admin details, or say the user permissions, or everything from the client side will be managed by this particular component in the client tool of the Informatica, right? What does this do? It contains the information about users or permissions, or say about each privilege for each role assigned, and the access which will be granted for that particular user. It contains all those details. Now how does this manage such kind of activities? It again confirms the user, and the user will be again correlated from the database in the repository. It will fetch the data with the help of the repository server, and then it will be seeing if the particular user has some kind of privileges, say for reading, if the particular user is assigned only for reading data, then he can be accessing only to read the data but not do any kind of updations, insertions or deletions, right? So these kind of managing functionalities will be performed by the repository manager. Then what else does it do? It even contains the say it contains the source or target connections, right? We are connecting from the client side to the server or the repository. So those kind of connection strings and the database connection details will be managed by the repository manager. And apart from that, it also has the details of folder structures, how everything will be say managed about from the source side or say from the target side. Everything, all those details will be saved in the repository manager, right? I'm making it easy for you to go through later. Yeah. So these are the basic functionalities of repository manager. Now coming to the Power Center Designer. Now what does this Power Center Designer do? We have to get the source and the target from a database. As I have said earlier, since for the data warehousing concept or say for using these kind of tools, the basic purpose is to extract data from heterogeneous data sources. Say one kind of data, one particular data you need to fetch it from a relational database, and another data you need to fetch it from a flat file, or say again from an XML file, or say from a web service. So when you have such kind of heterogeneous data sources, you need to define each source, right? So to fetch such kind of sources, and also based on your requirement, if you want to again save the data in the form of flat file, or say if you want to save it in a structured format, in a tabular format, in a relational database, or if you want to make it as a web service again. So based on your target and source definitions, you need to define it in the designer. So what does this Power Center Designer do? It helps you to create or define the source and target components. Okay. So apart from creator and defining the source and components, it also helps you to manage the source and target definitions as well. Okay. So there you are. It also manages the sources and targets again. Now apart from this, what else does it do? What else do you want your task to be performed? You have your source, you have your target. Now the main purpose of doing that such kind of thing is you want to transform the data to whichever required format you want to. Say if you want data from one particular table in a relational database, you want to fetch ID from a table, and then you want to fetch a first name from a flat file in another format. Now you want to transform the data saying I want the ID to be in the target table as say ID with unique ID and also the name, not only ID. So such kind of transformations, or say if you want to perform any other kind of aggregations apart from these kind of things, then you need to do such kind of activities in the Power Center Designer. So to perform such kind of activities or say transformations, you need to even define or create the mappings. These kind of mappings will help you to transform the data to whichever format you want, and then make your reports to look in a good way. Okay, there you are. Then what else does this Power Center Designer do? creates or say transforms the data, right? So you have fetched the source and target components, or say you have defined it, you have defined the mappings, and you have transformed the data. Now in these mappings you are just assigning or you are say just showing Informatica like you want the data to look in such a particular way. Now these kind of mappings will not be executed directly. To execute these kind of mappings, we need to work with the workflow manager, right? Now what does this workflow manager do? It creates or say manages the workflows. As I have said, to perform a particular task, the mapping has been defined to transform the data. But even to execute that, you need to take the help of a workflow. In this workflow, you will be having lot of jobs, say in the back end to be run, and then in the front end, you will be fetching the data. After the jobs will be run, and then you will be transforming it to the way you want, and then you will be if you want to schedule a particular task, even that kind of management will be done in the workflow manager, right? So what else does this do? It even creates or manages sessions or say tasks. Okay, and again we can even say you are not able to assign some kind of properties, or say you want to change the properties of each task in the runtime, then you can even manage such kind of runtime properties of each session or say each task in the workflow manager. Okay, now you have say executed the workflow, and then you want to see how it is going on. Say if you have if your job has run and it is triggering some kind of operations, DML operations, say some records have been inserted, some records have been updated, some have been removed from the table, and so on. So to find out such kind of data about what kind of operations have been performing, or say if there is a job which has insertions, updations and deletions. Okay, it's performing insertion and updation, but it's say not deleting the record which you want to do. So you have that kind of information, the session logs. Am I audible, team, now? Can anyone please confirm? Okay, yeah, that's great. So where was I? Yeah, the workflow manager. So what does this do? It creates or manages the workflows and creates the or manages the sessions or tasks, and also we can change the runtime properties of each session and manage it in the workflow manager. Now you have executed and you want to check the status of each task or say each job, if it's performed properly or not. So such kind of activities or say such kind of details you can find it in the workflow monitor. What does this do? It executes or say execution of workflows can be done in this. And what else does it do? It helps us to check the details of each task or say the session logs, right? Now what are the session logs? In this we'll be having the details of all the performed operations, whether they have been successfully executed, or say if we have any error, then it will be throwing an error to us saying that such particular operation has failed and you need to go through that. Okay. So this is another functionality of the workflow monitor. And what else does it do? It even allows us to schedule the tasks, or say the monitoring of a particular workflow can be done in the workflow monitor. Okay, so these are the basic functionalities of each component of Informatica client tool, right? So there we are. We have learned about what is a repository, we have seen what is a server doing, and what is the basic functionality of each component of client tool of Informatica. So here we are, and we can learn more into that once we install the software, and then we'll be having practice with that. Okay. Now let me save this as Informatica architecture details. Okay. This is just for your information that I have kept it, and I'll send it across. So we have learned more about the Informatica architecture now. Now we will see what are the different kinds of schemas available in the data warehousing and how we will be correlating that to Informatica. Okay. Now what is a schema? It's nothing but we designed say we want the database to be structured in a different way according to the requirement in a project, right? So we will be having in normal database our data is normalized, but as we have discussed earlier, in the data warehouse it is denormalized, right? Can everyone mute yourself, please? Yeah. So what are the different kinds of schemas available in the data warehousing concept? We have one called star schema. We have another one called the Snowflake schema, and we have something called the Galaxy schema. Okay. Now what is the star schema? This is the simplest form of schema available in the data warehousing. This is nothing but it contains one fact table with many dimension tables. Okay, in some cases this is again simple or complex. If you have a simple star schema, then you will be having only one fact table, okay, with some dimension tables. But if it's say a complex kind of structure, then you will be calling it as a complex star schema, and you will be having more than one fact tables in that. Okay, and you will be having many dimension tables as usual, like a simple star schema. We will see how that works. Okay, say for instance you have a table called let me name it okay, let me say take an example of sales table. Okay, you have sales table, and in that you have some columns like say product ID, and say you have something called store ID. Okay, and then you have something called time ID, and you have quantity, and then you have price. Okay, now what does this do? this says the fact table which is at the center, and then you have some other kind of tables in this one. Right? Say we have some dimension tables which are getting data from the, or say which sales table gets data from the dimension tables, or vice versa. Say if I name this table as say it is store, okay, and this has some fields like store ID, and say you have even the store name or something like that, and here again say we take another dimension table as time, which contain the date and the, say date timestamp or such kind of details, and then say you have another kind of table called product. Okay, so you have product ID, and then you have product name or some kind of description as well. Okay, so here what happens is all the dimension tables, they are correlated to the center sales table, right? What does the sales table do? It gets data of the, say the product ID, it fetches the product ID from the product table, store ID from the store table, time ID from the time table, and then it contains each kind of say the facts, that is the quantity, price, and the aggregation columns and such kind of measures will be there in the sales table. So that is the fact table which is at the center, and we have some kind of dimension tables like store, time, product, and say some other few tables, and which will be correlated to the sales table. So since this kind of structure is seen in the form of a star, there we call it as a star schema. Okay, this is the simplest form of data warehousing schema which we implement in any project. It depends upon the project whether we implement the star schema in a simple way or in a complex way, or we opt for a Snowflake or Galaxy schema, right? So there we got the picture of star schema. Let me save this. Let me name it as star schema. Okay. Then we have something called the Snowflake schema, right? Now what is the Snowflake schema? It is nothing but, it is again a star schema, or say a modification of star schema with some kind of normalization. Okay, say normalized star schema for some dimension tables. I have called this as a normalized, but it's not completely, I mean we have level of normalizations, right? So we do not find high level of normalizations like 3NF or such kind of normalizations in Snowflake schema. We just do it for the redundancy, to avoid redundancy of data. So the dimension tables are just normalized for some extent but not completely normalized in the case of Snowflake schema. But star schema is completely denormalized. I mean the dimension tables are completely denormalized. Okay, it's nothing but an modification of, or say the upgraded type of star schema. Okay. Now that's what I have said, that we can implement Snowflake or star schema or any a kind of schema based on the requirement in the project and based on the details, or say the structure which we want to go for. We'll see in detail how the Snowflake schema works. Say the Snowflake schema again has the same kind of thing. Let me open the same thing and then modify. Okay. So say we have again different kinds of fact tables and dimension tables. Now say this is again my sales fact table. This is say again the store dimension table. Say this is the time dimension table. Say this is the product dimension table. Okay. Now this is the structure we have seen in the star schema. Now what does this Snowflake schema do? We have say again some kind of dimension table coming out from the dimension table which is already there in the schema. We have sales fact table correlated to the product dimension table, and say we have some other kind of dimension table which will be attached to the product dimension table. So there comes the picture of a Snowflake schema. Okay, say this again has some kind of schema, and say this again has some kind of dimension table. Time has some kind of dimension table, and that again has another dimension table coming out. So this kind of architecture, so this kind of schema is termed to be as Snowflake schema, right? Here we have one fact table, and the different kind of, the splitting of dimension tables is being seen in the Snowflake schema because of the normalization, since the dimension tables are a bit normalized but not highly normalized. Okay, so there we are. Let me save this again as Snowflake schema. Okay. Then we have seen star in Snowflake. There is another kind of schema which is also called as galaxy schema. And what is this galaxy schema? It is nothing but dealing with many fact tables and many dimension tables, or say the consolidation of such kind of structure is called galaxy schema. This consists of many fact tables and huge number of dimension tables, and also in some cases you see the dimension tables common. Okay, can everyone please mute yourself? Dimension tables are common for the fact tables. Okay, this is the architecture which we see in the galaxy schema. We'll see how that works. Say here you have one fact table called, let me name it as sales. Okay, and then again you have another fact table called purchase. Okay, these are the two fact tables, and you have some kind of dimension tables which will be correlating to each kind of fact table. Say, for instance, for the sales table, you have a retailer who will be um, buying the goods. Okay, so the details of the retailer are present here in this dimension table. And then say if you have another kind of table called area. Okay, based on each area you will be providing the goods for each retailer. In a particular area you will be having again different kinds of retailers, and so what is the sales doing? We'll be having the measures for each retailer who will be buying the goods in quantity, the number of goods, and what is the price for the goods, and how they'll be delivered to each area. So all those measures will be there in the sales, and for each table, again the dimension table will be having the descriptions of each retailer, or say each particular area. Okay, so say these are correlated to this fact table, and this is again related to this fact table. Then we have, say, other dimension tables called here you have time, and say again here you have your product. Okay, this will be again correlated to the sales fact table. Now again, since you have the purchase fact table, what does this do? Say someone is supplying goods to this retailer, but they are not providing it directly. You have so many say tables to be to go through before going to a retailer from a supplier. So that supplier, he will be the dimension table to the purchase table, because someone is purchasing goods from the supplier, right? Say there is another dimension table called region. And what does this region table contain? So it contains the details of all the traders in a particular region for particular product. Okay, so that is again correlated to the purchase fact table. Now say the purchase fact table again correlates to the time dimension table and product dimension table. So here what we are seeing is the time dimension table and the product dimension table are correlated to two fact tables. I mean, the sales table gets information from time and product. Even the purchase table gets information from the product and time dimension tables, because someone is supplying goods, so they want to see what kind of products they are supplying to, and what is the information of it. If a supplier wants to get such kind of information, then he wants to get from the purchase, and which will be correlated to the product dimension table. And same is the case with sales table. So this kind of architecture or this kind of schema is called as Galaxy schema, since we have so many dimension tables with so many fact tables, and also apart from that we have correlation between the fact tables with common dimension tables, right? So that is the basic understanding of Galaxy schema. Let me name this as Galaxy schema. Galaxy schema is also called as integration schema, because we are integrating different kinds of dimension tables to the fact tables, and we are getting integrated data from this kind of architecture, right? So there we are. We have defined different kinds of schemas available in Informatica. So let me stop the session here. We are done for today. If you have got any questions, team, Please ask me now. I'll try to clarify your doubts. What is this? Schema Informatica. Okay. So that is what we have learned today. We have learned the basic understanding of the Informatica architecture, how the server and client work together, and how the schemas are designed in the data warehousing. Okay. So now I'm open to the questions. If you have got any questions, please go ahead because we are even running out of time. Yes, team, any questions? Team, what is a normalized table? Yeah, Pramila, normalization, we have three levels of normalization. The basic concept of normalization is like we need to get out of duplicacy, okay? I mean, the level of normalization depends on which kind of level of normalization we are applying on a table. So the basic concept is like to avoid data duplicacy or say redundancy, to have unique kind of data. We should not have say blank data or say such kind of atomicity. We'll be having all those concepts. That's a big chapter again. We'll discuss it in offline. You can drop me a mail about that and I'll just send you back the email. Sujata, the cost and the detailed course content will be published soon, I guess even today or tomorrow in the IT Learn site. You can just go through that and you can register yourself to the upcoming classes. And I guess from the next week onwards, we'll be having the premium students only will be allowed to such kind of classes. The demo sessions are already over for today. I mean till today. Yeah, thank you. So any other questions, team? If you have no other questions, then we can wind up the session. If you have any other queries or any other doubts, if you need to clarify something, you can just post your doubts into the forum of IT Learn site. We'll get back to you for sure. So there we are. Okay, thanks a lot for your patience, team, and that was really wonderful to have you all attending the session. Bye for now and see you next week to know more about Informatica Power Center. Right? Okay then. Thank you so much. Bye.